Bismillahirrahmanirrahim. I'd like to do one more example of binomial probability, which is a little different scenario. This I found on the internet. It was a gentleman did a very good job giving this example, I thought. So here it is. So let's imagine there is a new medication, that cures a disease. That is curative, at 8% success rate. That's a tough disease to cure, apparently, and the success rate is pretty bad. But 8% success rate, perhaps it's the first medicine for this disease. You never know. So the medication is when it has 8% success rate of curing the disease. Okay. So now let's say 15 patients. Okay, 15 patients are treated with this medicine. Okay, so what's the probability? Okay, what's the probability? The question is, what's the probability of at least? What's the probability of at least 2 people? Okay, being cured. Okay. Now, this is a tricky question if you look at it. What's the probability of at least 2 people being cured? In other words, you want like 2 people cured, 3 people cured, 4 people cured, all the way up to 15 people cured, right? But you want to know what's the chances that, at least 2 people will be cured, right? So, so if you want to find the answer to this, okay, you would have to do, there's probability of 2 people being cured, and then you have to find the probability of 3 people being cured, and then you have to find the probability of 4 people being cured, and then the probability of 5 people being cured, and then all the way up to probability of 15 people, and then add them all up, right? Okay, so at least means that you have to 2, 3, 4, okay, like that. Okay. Now, probability of 2 people being cured from the binomial theorem is like, it's easy, right? Probability of R events is combination N choose R, probability of failure to N minus R, and probability of success to R. Okay, so if you wanted to see 2, it would be 2, and so failure rate, and that's a success rate, is 0.92 to 15 minus 2, and the success rate is 0.08 to 2. That's what you would do. That's probability of 2, and you would have to do that for every single one of these and add them all up. That sounds like a very long problem, right? Yes, it is. But the point of this problem is to show you the shortcut, and that is probability of at least 2 people being cured. If you find the probability of nobody being cured, and then if you find the probability of at least one person being cured, if you add them together, right? That's going to be easier to do. And then you take this, right? And then you subtract this from 1, because all probability you have to add up to 1. It'll give you probability to the rest of them, right? Because all possibilities are probability of 0 people, probability of 1 people, plus probability of all of these. If you find this, okay, and subtract that from 1, it will give you the probability of this. So probability of all of the possible events added together gives you 1. Okay, so that's the key. The probability of all possible outcomes added together will give you 1. It's like heads and tails. Probability of heads, half. Probability of tails, half. Add them together, 1. Like that. So it's easier to do 2 calculations than it is to do 13 calculations or whatever. So in this case, the probability of at least 2 people being cured is going to be 1 minus the probability of nobody being cured. That's possible. It's always going to work. And minus the probability of 1 person being cured. Okay, so that's what you have to do over here. So it's going to be 1 minus probability of 0 person is, and now you have 15 people, choose 0. Now probability of failure is 92% of 15 minus 0. Probability of success is 0.08% to probability of 0. Minus the probability of 1 person, which is 15, choose 1. Probability of failure is 0.92 to to 14, and probability of success 0.08 to 1. Okay, so let's do progressive logical reasoning, baby steps. Let's add, okay, let's do this. 15, choose 0. Probability of failure is it's pretty high, not a good drug. What are you going to do? Okay, it's to 15, and probability of success is 0.0, whoopsie daisy, 0.082, 0.08, yes, to 0. Okay, so that's the probability of having nobody. Okay, that's 0.89. Let's round that off to 0.89. So 0. That's 0.89, 0.29, right? So what is it? 0.29, 0.29. So that's 0.29 minus, okay, 15, choose 1. So that's 15, choose 1 person success. So this is going to be 14. And that's going to be 1. And that's 0.37. So it's going to 0.37. 0.37. Okay, so now we do the math. Okay, so 0.37, 0.29. So we do 1 minus 0.29 minus 0.37. Okay, it's 0.34. Is 0.34. I just kind of rounded it up over here. Okay, 0.34, and this is 34%. Got it? So the probability of at least 2 people succeeding, if I did the math correctly over here, and inshallah, is 34%. Pretty good, not bad. Okay, so 34% success rate. So sometimes you have to be very creative with some of these. You have to think through, and this is the binomial probability, and the formula for the binomial probability is this: failures to n minus r and n minus r to successes to r. And you just write this like 100 times or whatever, or however many times it takes for you to know this and know that really, really well. And until next time, then, wassalatu wassalamu ala rasulillah. Assalamu alaikum.